Hi. Lately we have been asked if we have a mid-surface feature, and we had to admit that we don't have it. So people searched for it and didn't find anything, and we really don't have it at the moment. So what you can do to extract the mid-surface of such a body or a more complex body is you can use your favorite tool that can do something like that. So for example, we could use Hypermesh from Altair. And you have to find out how the workflow works in this software. So for example, you can import this part there, take a look, and then use this mid-surface feature. It has some auto mid-surface stuff. So in the simplest case, I can just select some solids, call extract, and then I see a new component which is called a mid-surface surface or middle surface, and then I can export everything that I can see, or maybe it's even simpler to just delete this solid component and then export the stuff to some file and then import it back again into ELISE. But for sure you don't want to do this manually because we are an automation toolkit. And for this purpose you could as well just run these commands inside ELISE. So I want to show you how to do this. And I prepared a little file which is called mid-surface hypermesh, but actually you can use it as a template for any automation of anything. And these scripted automations make sense if you have a cool feature that is missing in ELISE, and this cool feature is available in another software, and this other software has a scripting or macro interface or some other naming for automation inside this software, or you want to test some automation quickly without writing a real component. So you could as well make an app, but maybe you're no developer and don't feel comfortable writing real code. So you could go for such a scripting automation then. I used Hypermesh Altair in this example, but the following steps are quite similar for any software you want to automate. So first you need to find out how to automate the software via scripts or macros, and find out how the data can be passed between ELISE and the other software. If you found this information, then you need to record the script for the desired workflow, and I already clicked this workflow, and in Hypermesh there's a quite cool feature. It always records everything in such command TCL. It's placed in documents. So in this case it's command 1 TCL because I have several versions of Altair installed, and this looks like that. Not very pretty, but if you go to the bottom of the page, you will see all the commands that you ran, the latest, and you can see what you did there. So for example, geom import was for importing geometry. There's always some stuff that you don't really need there. That's the viewer command. It just sets the niceness of the viewer and some rotations, so you can ignore these. So you have to dig around a bit, and for example, go to create mark solids, and then you see some mid-surface extraction, and then the solids were deleted, and in the end there's a geometry export. So most of the commands make sense by their naming, so it's quite easy to find out what they are for. And once you have these commands, then you need to parameterize them on the canvas and execute them. So I'll show you how to do this. We can replicate the same procedure as we did using our components. So first we need to export the geometry to some file path. Probably it's best to do a relative file path. Then there's some specifics about Hypermesh. You need to replace the backslashes with a normal slash to mark some file paths. And then I just copied this geom import command and put it into 2 panels. And in the middle of that panel, we merge our file path for the geometry export file. And then there are these mid-surface commands. So basically you need to parameterize what you want to have as a parameter in the script, and then write this script to a text file. For Hypermesh it's called TCL, and go on and run the Hypermesh executable with this TCL path. And if nothing goes wrong, you can use the exported file and import it here and put this all into one include function, and there you go, and you have your mid-surface.